Okay, imagine you are moving in your car with a velocity v car as shown here, and you pull out your hand from the window. So you can imagine that you will feel a tremendous force on your hand due to the air. And in this problem, we will be basically estimating that force in terms of the maximum pressure acting on your hand when you pull it out in a moving car by the application of the Bernoulli equation. So from your lecture, you might know that to apply Bernoulli equation, we first need to make sure that all the assumptions that go into deriving Bernoulli equation are applicable. I'll write them quickly here. So first one is we have inviscid flow. So this just means the viscous effects are very small, and one of the way in which viscous effects will be small is that the velocity gradients are basically negligible. The second assumption is that the fluid is incompressible. The third is steady state. And the fourth is we need to apply Bernoulli equation along a streamline. So here, since the car is moving with a constant velocity, you can imagine the velocity gradients are zero because we have a constant velocity, and the air can be assumed to be incompressible if its Mach number is below zero point 0.3. So this when you are moving in a car, it is usually true, and you can assume air to be incompressible in this case. And also steady state uh, assumption is also true here because the car is moving with a constant velocity. So let's just we can apply Bernoulli equation in this case along a streamline. But to apply Bernoulli equation uh, in an easier way, let's just choose a coordinate system which is attached to the car. So in a coordinate system which is moving to the car, moving with the same velocity as the car, what you will see is that basically, let's say if this is your hand eh, out of the car, and you are working in a frame of reference attached to the car, what you will see is that you will see the air is moving towards you at a velocity v car and pressure v atm, basically the atmospheric pressure of the air. And now as a streamline far away from in the air moves closer to your hand, it basically stops at your hand because your hand is stationary in this frame of reference, and it basically what it is doing is it is stopping the air. Um, so let's say we choose 2 points, point 1, which is far away in the air, and there the velocity is v car and pressure is p atm, and point 2, which is near your hand. So v2 is basically 0, so it is a stagnation point. And pressure there is P2, which is an unknown, and we would like to find out what that pressure is. So Bernoulli equations tells us that P1 plus half rho V1 square plus rho G Z1 is equal to P2 plus half rho V2 square plus rho G Z2. So since Z1 and Z2 are the same, we are considering a streamline which is horizontal. We can get rid of these two terms. So P2 will be simply P1 plus half rho V1 square minus V2 square. And since point 2 is a stagnation point, V2 is 0 and V1 is V car and P1 is atmospheric pressure P atm. So P2 is basically P atmosphere plus half rho V car square. So this is the pressure that your hand will feel and in terms of gauge pressure, your hand will feel half rho V car square. This much gauge pressure. So that's it. This problem was simple. We just applied Bernoulli equation to find out the maximum pressure your hand will feel when you pull it out of a car moving at a constant speed.